Yeah, all right. So I'm Avinash Vallarapu. You can call me Avi. I work for Percona. And how many of you have attended the PostgreSQL tutorial that I presented some time back? Okay, 4 of you. Okay, that's great. All right, so mostly I would not be talking about what I discussed there for sure. So what we are going to discuss here today is about how we can build an enterprise grade PostgreSQL using open source tools and extensions in PostgreSQL. For example, like we always think that, especially, or most of us might think, when we are deploying open source databases, we may not get all the enterprise features that we may need. We may have to go for some vendor, or maybe we need to get some kind of a tweaked enterprise product which is built on top of the community software. Maybe that's commercially marketed as enterprise version, could be, right? So like we see Oracle Enterprise Manager, Oracle Enterprise version, as well as some other databases, even in PostgreSQL, like we have several folks that are commercial and they're not free, right? So we kind of get into an assumption sometimes, especially when we have large enterprise setups, that we need some kind of licensing, else we might miss some of the features. So this talk is more towards making it easy for people who think that we need licensing, right? So that we can actually avoid that thought and start thinking like, okay, we can definitely build an enterprise grade Postgres even using open source tools that are available today. So just a little about Percona, like we kind of provide enterprise grade support for any database, and there is no license. Everything that you see here is free, right? And shortly you might hear something about PostgreSQL soon. Do subscribe to our blog post, and you would hear some announcement. All right, so now what are some of the enterprise features that everybody might look for, right? So encryption. I don't think open source databases provide an option for encryption by default, right? This is some kind of thought that people may have. User management. Do I have all the options to tune my database server, right? And I would like to utilize the computing power of master and standby and do load balancing, connection pooling, right? Is that possible for free, or maybe should I need to go for enterprise subscription, right? And also logging, auditing, monitoring, right? High availability, backups, and more importantly, the maintenance tasks that you would want to perform all the time, because you just not run your database and let it go, right? I mean, you need to keep on maintaining it all the time. You have several list of maintenance tasks that you perform, but do I have all the options to perform the maintenance tasks without causing any downtime, right? Partitioning, continuous bug fixes, security vulnerabilities, and many more. I mean, it's just a small list, right? So these are kind of things that we might think of while deploying an open source setup, right? So some blog posts for your reference. These slides will be available. So we kind of have grouped them into some of blog posts so that later you can revise. I mean, you can go ahead and read a lot more about each of those and how to achieve that in some of the blog posts that you see here, right? So let's start with security in Postgres, right? So whatever we are going to discuss today is something that's available by default with the community version of PostgreSQL, right? Or something that can be attached to it in the form of the open source extensions or some other open source tools that are maintained by a big list of community right? And it's not something that you could think of that, okay, it may be just a product that's available for free but not well tested, right? I mean, we are going to talk about only those extensions and tools that are well tested. I'm sorry. All right, so talking about authentication, Postgres, how many of you have worked on PostgreSQL or have got good knowledge on PostgreSQL today? All right, okay, great. So PostgreSQL does allow a variety of security standards starting from authentication, authorization, accounting and auditing, and even security bug fixes. I'll explain you how. So starting from authentication, you have a host-based configuration file in host-based authentication file in Postgres that acts as a built-in firewall, right? So you could restrict who could connect from which IP, right? So that can be a combination of database name, username, host name, and also different type of authentication methods. So you could integrate it with LDAP, and you could also enable encryption of data over wire using SSL, right? And that's something that's available by default with Postgres. You really don't have to do much about it. So talking about authorization, you also have a finest level of row level security. That means a manager, you can have such a kind of a fine-grained access enabled in a way that a manager could only see the records of his own employees in a table, right? Let's consider an employee table, and let's say we have a manager column. A specific manager can only see the records for which he is a manager, right? So such kind of a row level security, a fine-grained access can be configured by default with Postgres today. And even user management, you talk about segregation of users through roles and privileges, right? Like we have in Oracle. So you could go ahead and even create users, roles, and also grants and privileges can be assigned to users and roles, and you could definitely go ahead and set up a proper user management. And at the same time, you can also enable detailed logging of all the activity, right? And there are some extensions like PG Audit that also could help you understand some kind of SQL injections that could happen. And talking about security bug fixes, PostgreSQL community takes all the security bugs as well as any PostgreSQL bug very seriously. So that is why if you would have subscribed to PGSQL mailing list already, that'll be great. However, if you have not subscribed to it already, just search for PostgreSQL mailing list in Google, and if you do that, you could go ahead and subscribe to PGSQL hackers, right? And there are some other mailing lists that you could subscribe to, but you would definitely get a lot of mails. So just filter them, but notice them, right? Like you could see if somebody raises a concern sometime about a security fix or a bug, right? You see too many people immediately responding, and some fix to it is available in minutes, right? So it's a very big community that always takes care of security bug fixes, etc., very seriously. So in fact, even if in case there is a fork of Postgres that's built as a commercial PostgreSQL fork, right? Even if they need to apply the bug fix, they cannot backport that to the open source Postgres again. So they'll always be behind some versions or some minor versions of the latest community version. So we always need to understand that community is definitely advanced. Backup strategy. So I remember, like when I used to work on Oracle databases, unless I go to an Oracle Enterprise version, likewise several other databases, unless we go for an enterprise version, we cannot configure a backup strategy that can allow us to achieve a point-in-time recovery online, like RMN kind of backup in Oracle, or there are some other backup tools available for other commercial databases, database softwares, where you cannot take online consistent backups. Is that what it is with Postgres today? No. Postgres does support logical backups, right? That could help you with maybe non-production refreshes, or some other if you would like to go ahead and perform just the backup of the data only in a way that you avoid all the fragmentation, and all the fragmentation is gone from the database, right? Maybe these logical backups could be helpful. At the same time, you could achieve consistent online backup that helps you achieve point-in-time recovery using PG-based backup, and that's available with Postgres today, right? However, PG-based backup today cannot be taken using multiple parallel jobs, right? So it only runs in one process option. So if you would like to have a parallel backup feature, there are some other open source backup tools like PG Backrest, Barman, Volgy. PG Backrest is one of the backup solutions that is available in PostgreSQL for streaming your backups even to cloud without storing the backups locally, right? So if you have a 1 terabyte database server, I would suggest you to try PG Backrest, because it also supports not just parallel but also incremental and differential backups, right? So this is something that could be helpful when you also would like to go ahead and use the standby, the replicas computing power for backups, because PG Backrest can also work from slave, your standby servers. So you can take backups on your standby. So, or you could configure an additional standby that is only used for backup purposes if you're afraid of the system resources for backup. And it also performs a parallel restore. So take a note of all these tools that could be helpful for you in case in the future you want to set up an enterprise grade Postgres just using all the open source tools, because these are the ones that are used by more number of people across the world. Yes, go ahead.
Do you want to ask questions now or wait till the very end?
Go ahead, I mean, it's okay.
From what you're describing, PG Backrest is that an open source?
It is open source, yes.
So why is it not like backported into Postgres so it becomes part of the standard build?
Right. So community has certain standards, right? So and apart from that, PG Backrest especially is actually coded in Python initially, and now it's being written in Golang, right? And there are some of the extensions, I mean, or some of the tools that can be converted as extensions and added to Postgres. At the same time, Postgres community does not just accept any code or any project that you could just code yourself and push it. Unfortunately, the reason is they definitely follow a lot of standards, due to which most of the features that are committed or contributed by many people are not just simply added. It took several years. For example, PG Logical, it's one of the extension, right? That's been there since quite a lot of years, and so by the time we released logical replication and logical decoding in Postgres, it's now in Postgres 10. So there are a lot of standards that are followed by the community. So not everything is accepted or backported, but PG Backrest or some of the backup tools are still available in the PGDG repository that's maintained by the community, right? However, this cannot be just backported because it's the way that it's coded, right? If it can be an extension, yes, that's different, but this cannot be an extension because they used a different programming language and it's a total different approach.
Is there a workaround how that can be used in AWS, on RDS?
Definitely no, I would say. On RDS, if you would like to use a backup solution, it can only be PG dump, PG restore. But if the problem is AWS, RDS, all these DBAS, like you would not get access to the file system, right? These are all file system level backups, like all the backup tools that you see here, except for the logical backup, right? Yeah. But RDS, of course, they have all that command line clickable options where you can configure, your backups. Yeah, no, I don't think there's much of a access to that. Yeah.
Can you run these PG Backrest on the target versus source in fully?
Can we run PG backrest on?
The target where you are replicating, right?
Yes, we can.
That way you can work around RDS, right?
So when you say work, I mean like from a remote,
Right.
yes.
From the remote pulling the data from
That's right. But RDS only gives you access to the database, not the file system. And that's a problem. So you cannot go ahead and stream your transaction logs as well as the contents of the data directory, right, the file system. So that's something that PG backrest does internally. Yeah.
Yeah, I think you asked for the workaround. If you have database replicating from RDS, then you can back up the replica, not the RDS itself.
Yeah, but
Yeah, because that was the question.
okay, but can you replicate a database on RDS to an EC2 kind of a? No, right? So, but if you have, I mean, if that was your question, like if we can have a replica out of the RDS, again, that has to be another DBAAS. However, there can be one solution where you could use maybe logical replication, but that again is not something that you could create here. So it can be a logical PG logical, or no, it doesn't work that way because that only works from RDS to RDS. So we need to have some other mechanism using which we can replicate the changes on the RDS, right? Using custom triggers or something, right? That way, if we can stream all the data from RDS, yes, on the target, you could. Yeah. DMS, yeah, DMS for sure. DMS is something that you could use when your target is RDS for sure. I am not sure if your source is RDS. I mean, if your target is non-RDS, right? If your source is RDS and target is non-RDS, I doubt.
There might be some workaround to dump it into S3 or something.
Yeah, you can use Bucardo to replicate.
Bucardo is something, yeah, definitely you could use. Unfortunately, that's not supported anymore. Sloaney is something that needs, again, yeah, so Bucardo is something that I've used some time back. It was 2-3 years ago to replicate 8.2 Postgres to 9.5. But that itself was not supported that time. I mean, like, it crashes like anything. We had to do a lot of code changes. It's done in Perl, and it's still way too old now. I mean, yeah.
For on-prem solutions, does Barman work with NetApp-like appliances?
Yes, it will. It will, yes. Yeah. All right. Connection pooling, one of the important topics that you should understand why we need connection pooling, and at the same time, you should also understand some of the open source tools and extensions available. So if you have already heard my talk, if you would have attended the tutorial, you might have understood that Postgres is process-based. So every connection that you're getting to Postgres is actually a process in the operating system. So there is a super user or a super process or a master process called postmaster that listens to the connection first, and it forks a backend process for each user connection. So this process creation, right, and terminating the process, cleaning up the resources is one of the complex activities on the database server. Your database server can scale if it's up to some number of transactions per second with that approach. But when you know that these processes, the creating the process and terminating those processes, if that's a bottleneck, that's when you kind of need to go ahead and think of a connection pooler. So one of the lightweight, or I could say more than 90% of the PostgreSQL database environments have implemented, right? It is PG Bouncer. This is implemented at almost every PostgreSQL environment today. So PG Bouncer, what it does is, it's a lightweight connection pooler that goes ahead and creates some persistent connections on the database server and your application could just reuse those persistent connections. But do you really need a PG bouncer when you have an application connection pooler? No. The first preference goes to your application connection pooler. And if you know that you cannot set up an application level connection pooler, that is when you should think of an external connection pooler like PG bouncer that understands the Postgres protocol, right? So if you have seen that your server resources are getting overutilized and you're not able to scale your Postgres and you do not have a connection pooler, definitely go ahead and think about PG bouncer, right? Where should this be running? Preferably on the application server, because you might have got high availability on your application server, right? If you would have got one active and one passive application servers, right? I mean, then you should just have PG bouncer running on both active and passive. If any of the service on the application is down, fail over to the other application server. So that kind of a logic you can set up at least. PG pool 2, like that's also one of the connection poolers, and that's more than a connection pooler. It can also manage high availability, automatic failover, right? And load balancing. But this is something that could be heavy for your database server, especially because maintaining PG pool is like maintaining another Postgres, because in PG bouncer it's thread, right? But in PG pool 2, every connection that it gets from the application is again a process. And again, what it does additionally is it parses every SQL that's sent from the application to the database, and it understands whether that's a read or a write query to load balance it and redirect only read queries to standby and write queries to master, right? So it could do such parsing of an SQL and push SQLs to master or slave, and you do not have to put your own logic there, right? PG pool can definitely help you, but always test your performance. I mean, perform benchmarks and then implement PG pool 2 when you think you can. And you could definitely use HA proxy for load balancing, and you could even combine PG bouncer and HA proxy, right? How do you do that? I mean, I hope everybody understands what an HA proxy is here, right? Okay, so it is something that you could use for load balancing, right? Like in several, I mean, it can accept several algorithms like round robin or least connection, right? I mean, so if you have more number of read queries on your database, I mean, that are hitting your database server, what you could do is your application can use the HA proxy. It could connect to HA proxy for read connections, and HA proxy could load balance those reads across master, standby, and maybe another standby or n standbys, right? So you could use HA proxy. And how do you combine PG bouncer and HA proxy? So in PG bouncer, you can have two connection strings, one for writes and another for reads, and that reads should go to HA proxy and the writes should go to master, right? So what happens is you're also getting the advantage of connection pooling, and you're also getting the advantage of load balancing. But the only catch here is that your application should be able to push writes to a connection string and reads to another connection string. If your application is not coded in such intelligent way, then that doesn't work, right? But it's really important today that we need to make them, I mean, when we are building an application, we need to make sure that we are able to distribute such kind of activity from the application itself. We should not push that logic to the database. When we do that, we need to use PG pool or some other proxy solutions that can parse the SQL, but that's always an overhead, right, which can be avoided if the application can be coded well.
Question, please.
Yes.
Can you have two HA proxy in front of a PG bouncer, or can you have just for fault tolerance? Because now we are adding an HA proxy to increase HA, but we are adding also a one point of failure.
Right. So in one of the environments, right? I mean, I'll give you two examples of two different customer environments, how we implement it. So in one of the customer environments, like we had an active application server, and also my shadow, okay. All right, and also another passive application server, right? So we had PG Bouncer and HA proxy on the application server. So there is another service on top of it which was going ahead, I mean especially the web servers are connecting to another proxy solution. So it is, I mean there is another monitoring solution which is enabled to make this application server die if at least one of the services is down, because an application server might have got not just these two but several number of services that are running, right? Automatically the second application server becomes the active server. That's one way. Or the other way is to, again, that will add some more complexity, right? Like add an HA proxy here again and put another layer here that has got PG Bouncer, PG Bouncer, PG Bouncer, and HA proxy again, HA proxy again. Like either of this will be active all the time, right? But that adds more complexity. But I've seen this working. I mean, there are environments where PG Bouncer has been just up for 3 or 4 years, right? I mean, even HA proxy. I mean, they are very lightweight tool, lightweight services. I don't think it's really complicated to maintain those solutions, right? So it's good to keep them on the application server. Sorry. Okay, so high availability and automatic failover. I'm just checking the time that we have. Okay, great. All right, so talking about, I'm also going to do a demo quickly as time permits, but so talking about high availability, we have two replication solutions that are available with Postgres, and I'm going to suggest you which one should be the best for high availability as well. So streaming replication, logical replication. Streaming replication is considered to be binary replication. Rather, you could say storage level replication, because walls, write ahead logs, also called as transaction logs, that contains the change vectors, right? So what happens, like where is your data? Data is in tables. Where are those tables? Tables are stored in the file system. And how are those tables stored? How is that data stored? So to store data, multiple blocks are allocated to the table, which is nothing but a file in the file system, right? So whenever these pages or blocks have got some changes recorded, those wall records will be shifted or stored in the transaction logs, nothing but write ahead logs. So those write ahead logs are streamed to a standby. I hope I'm not making anybody sleep, right? But these walls are applied on the replica. However, you do have synchronous, asynchronous replication available with streaming, and at the same time you could also perform your read queries, but you can never write to a replica when you configure streaming replication. That's one of the beautiful things, because nobody can damage that manually, and it is never ever possible that there can be a table with 100 records in master and only 80 records in standby, right? That kind of that kind of issue cannot be possible at all unless your database is corrupted, which is a totally different scenario, right? So nobody can really do any damage unless you have forcefully put some parameters like or done something like making a table unlogged, right? So that the changes of the table are not recorded to the transaction log. So those kind of things can be done, but this is one of the replication methods that you should be using for high availability, right? You could also go for logical replication, because both does offer cascaded, synchronous, everything. But logical replication is a replication that you could enable for selected schema or tables, right? And it does have its own overhead, but if I would suggest a replication, and at the same time, let's say you perform some DDL changes or any other changes, not everything can be shipped automatically, but with streaming, it's just a blind apply. Anything you do on the master is automatically replicated to the standby. So that is why it's always a preferred solution for high availability. And talking about automatic failover, you have a big list of solutions available, right? Percona is definitely something that you should always try to test with, because it has got a great popularity, because it at least offers 5 nines of availability, right? So I mean, you could say that your system is 99.999% available if you would have deployed Percona, even 7 nines. Rep Manager is something that you could use to store on. PG Auto Failover is the contributions by Microsoft recently, right? It's done by Citus Data, and it's now Microsoft's baby. So I mean, they have released the first version of PG Auto Failover recently. I've done some testing, but it does need some more I would say development to make sure that the heartbeat checkers, the monitor has got some high availability, but Percona is something that you could always use, and these are some of the other high availability solutions. So how does, yeah?
So I'm guessing that the asynchronous works when database is non-archive.
Asynchronous replication works even when the database is in archive mode.
Yeah, it is always.
Yeah.
For non-archive mode, is that the preferred method, or is that the only method? Or?
So are you from the Oracle background? Okay. So in Oracle, the archive mode is a little different from how it is in Postgres, right? So what is archiving in Postgres? Archiving in Postgres is archiving or just copying the transaction log, which is WAL, to another location. It can be S3 or it can be any other file system, right, or another remote server. Why should we do that archiving, and who does that, right? Why should we do that? We should do that because all these transaction logs are generated and stored in the transaction log directory, which is pg_wal or pg_xlog, and you don't see those transaction logs stored forever. There is a retention, and if they are gone, even if you have a full backup available, you cannot perform point in time recovery to a point back in time because you don't have the transaction logs. So to avoid that, we would configure archiving and tell Postgres what to do for archiving through a shell command or a script, right? So Postgres itself runs that script or that shell command and archives the transaction log. So you don't have to enable it for replication, but what happens is when there is a huge lag and these transaction logs are gone, your replica can just not catch up anymore. You have to rebuild the replication again. So that is why archiving is preferred. You could also use replication slots in such a case, right? So the transaction logs on master are not gone or removed unless and until they are applied on a standby, right? But always archiving is important because it helps you achieve point in time recovery, right? Yeah, so this is how the Percona architecture looks like. Yeah, go ahead, sorry.
Is there any limit on the number of nodes you can have with Percona?
Number of nodes with Percona. There is no limit. I mean, it's at least 3 nodes that you need to set up with Percona today, right? And talking about the limit, I'm not sure of that, but I know that it is 3 nodes, but you can always add more and more nodes for sure, right? Because Postgres does allow n cascaded replication, right? So you could always add more and more cascaded replicas to those servers, yes. Yeah, I mean, it's just not 3, I would say, with this setup, yeah. So this is how the Percona architecture looks like, just to keep it simple. So etcd will be running. I mean, I'm keeping it more basic because Percona is a vast topic, but you just need to know that Percona is something that you could use. So etcd is a distributed consensus key value store that is being used to store the heartbeats like consensus, or is something that helps in leader election. So which should be the master? If I'm receiving heartbeats, right, polling from all the servers, then everything is available. And if I'm not getting the polling from master, right, then if the other two standbys are able to poll, right, so who should be the next leader? That is something that depends on the key value store etcd. So Petroni talks to etcd and then performs the action. At the same time, you could also go ahead and start a service like OS Watcher, right, or Watchdog, or or a soft dog that could shoot the node to avoid split brain, right? Let's say it's not able to poll, in the elections, right? It'll shoot the node itself to avoid that split brain. So it definitely has got such a nice architecture built in. And even if in case, let's say it performed a failover, now when this old master or primary got back up, right, it could go ahead and rebuild that using PG rewind, so that if it's a 1 terabyte database server, it doesn't again need to copy all that. It just resyncs using PG rewind, right? That's another tool that can just start that. And at the same time, you could always tell Petroni not to fail over when there is a lag of more than some time. Usually when you are configuring automatic failover, it is suggested to set up synchronous replication, right, so that at least one of the standbys have got the data that's committed on the master, right? So if you have a synchronous replication, you set up Petroni, no more data loss for sure, and at the same time it's definitely high available. Why HA proxy on the top? Because Petroni exposes APIs through which you could know what is a master and what is a standby or a slave, right? So which one accepts write and which one accepts reads. So an application does not need to know what is a master or standby. It just connects to HA proxy, and HA proxy can redirect the application automatically to a master or standby if it's a writes or a reads connection, right? So we'll see how that happens too very quickly. Sure. Yeah, so regarding the, yeah, I would show you that. So what happens here is so these two standbys are actually replicating the changes from just one single master.
All the standbys, like n standbys, will have one master.
Yeah, but you could definitely configure another standby to this, to this, to this. It doesn't matter. You could do that. Yes, you could do that in Postgres. Of again, yes, you could do that. Yeah. All right. So what I'm quickly doing for, here is it clear? Okay. Yes. Great. So I've got a 3-node Petroni's setup, and I'm going to show you how things are seamless for me, right? So this is my master, and what I'm going to do here is I'm going to use this simple Petroni CTL command line, and that's a YAML file that has got the configuration details. I'm not going to get into that, but so this is the name of my cluster. So PG0, PG1, PG2, these are my 3 nodes. Currently the leader is PG0. So that's my master, right? So what I'm doing is here I've got my application server, right? And what I'm going to do is I've got a Python script here that always tries to connect only to a master, right? So I'm not making any changes on the application when a failover is happening, right? So what it says is right now 172.303.133, that's a master. Let's go ahead and simply perform a failover. Okay, it's so simple if in case you have to plan planned failovers or switchovers, right? Now it says what should be the new master. So I say okay, make PG1 the new master. Okay, so it's asking me for permission to do that. Okay, it's done. Now what I'm going to do is I'll again list it. So I see PG1 is the new leader, new master, and PG0 is again running as a standby. Now you see it started connecting to the new IP, right? The new master. How is that happening in the back end? I could also perform another failover again, okay, just to make sure that I'm not trying to cheat with any scripting in the back end, which I would have done maybe some 10 years ago, not now, but yeah, so okay, you see now it's back to same master again. What's happening in the back end, right? So how is it so seamless to my application? What my Python script is actually doing is it's just doing a write, like an insert, nothing else. So I'm going to show you the HA proxy configuration file quickly, and this is available on one of my blog posts too. Okay, so my write connection, the insert, is connecting to the port 5000 of this HA proxy server, right? And what it is actually doing is it is trying to do an HTTP check and retrieving whatever returns its status as master, right? Here if I'm connecting to 5001, it's checking for the status as replica. So if my application connects to 5001 port, it only redirects my connections to the standbys that are state replica. And if I'm connecting to 5000 port, right, it only connects to that server that has got the state as master. So this is all done just by connecting to the Percona and checking, okay, what is your current state, right? So that's something pretty simply possible. So in your application you should only be able to distinguish your writes and reads. That's it. So your reads can be sent to one port and writes to one port. So it's just a simple change in the application configuration file just once, and that's it, right? So not just Percona. So usually in Postgres, let's say you set up synchronous standby names, right? Yeah, in streaming replication. If at least one of the standby is able to say that it got its change, right, then a success message is sent to the client. However, you cannot configure multiple synchronous, yes, but using Percona, just using Percona. Using streaming replication, you can have synchronous standby names as one comma another, yeah, but with Percona you could only set up, like you have the parameter using which you need to tell which one needs to be in replication, or it works similar to Postgres, but you cannot have multiple synchronous standbys today, right? So there are around 90 parameters that you could set with Percona today, and I don't think I've seen that option for multiple, but I can check that for sure. Yeah. So quickly, we only have 5 minutes, so I would go ahead and so some of the feature-rich extensions that you could use in Postgres, and they are available for free, available in the PGDG repository, right? And so one of them is pgstat statements. So if you would have worked on Oracle, you would have seen AWR, right? Like there is a view called DBA HistActive Session History that actually stores history of all my SQLs. What execution plan and how much time it took, block stats, right? Similarly, you could use pgstat statements, but it's kind of a summation of the whole duration and the number of blocks, block activity until the time you query. So for example, you have created the extension and you ran select star from foo.bar 100 times. You only see one entry that says query ID and the statement, total number of execution, total time, min time, max time, but that's something that could be used for query tuning, right? pgrepack. This is one of the extensions that's available if you should need to perform online table reorg, right? Like DBMS redefinition in Oracle or PT online schema change in MySQL, right? So you could go ahead and rebuild a table or indexes of a table or a specific index, or even move a table to another new table space which is on a different disk online, right? PL profiler. Let's say I've got stored procedures. I know if I've got an SQL, it can take care of that. Online, yes. Even indexes today, you can rebuild it online using create index concurrently. Yes. Whenever you usually perform a vacuum full or a pgrepack on a table, it automatically rebuilds the indexes as well, yes, because it's creating another table, copying the data, creating triggers internally, and recreating the indexes, applying the changes, right? Yeah. PL profiler. This is one of the extensions that could help you get call stack of each call in your stored procedure, like an HTML report, right? And that's something that could be helpful, not just to tune your SQLs, but even your stored procedures. Or a face. I've used Oracle so far, right? Most of the Postgres users today are Oracle. Let's say I've used Oracle so far and I want to get some nice functions like DBMS underscore, all those that we have seen in Oracle until today. You could use this extension and it helps you, select from dual or everything that you could do with Oracle almost. And there are many good language extensions. And you could use foreign data wrappers to connect to another database server that is not just Postgres. So you could remotely query MySQL or MongoDB or even Hadoop, right? And you could join, you could push the aggregates, you could even go ahead and not just join right to it, right? So there are a lot of such options that are possible, and all this is for free, right? You don't have to do anything. You don't have to pay anybody to get these extensions or tools. Please don't pay. So logging and analyzing, like you can log DDLs, you can enable detail logging, and in order to generate a report on everything that's logged in the log files, you could use PG Badger. That automatically generates a nice, beautiful report on what are the time-consuming SQLs, what SQLs may need to be tuned. And you could use Percona's monitoring and management solution. And query analytics is still under development. And these are some of the solutions that are available for monitoring. This is my last slide, right? So PMM is something that you could use for sure, and you could expect some good dashboards on Postgres with good monitoring shortly in PMM version 2. However, we do have good amount of blog posts, dashboards today for PostgreSQL as well. And these are some of the other open source tools that you could use, or some of the other tools that you may need to pay, but you could definitely use any of these monitoring tools. So this was the setup that we talked about, how you can combine PG Bouncer and HA proxy already. So I think we're done. And thank you to our sponsors. You can definitely rate my session. How will I let you sleep, or if I really made you sleep, but yeah, thank you.